If you look at Europa from a distance, and I don't mean the continent, I mean the moon, it looks almost perfect. A smooth white sphere, etched with thin reddish lines as if someone had painted fine porcelain. There are no towering mountains here, no gaping canyons, just a serene, icy desert, roughly the size of our own moon. But that tranquility is a lie. The surface is nothing more than a mask. In this investigation, we're going to peel that mask away. We'll explore why scientists are now almost certain that a global saltwater ocean is hiding beneath that ice. We'll see how it manages to stay liquid in the freezing void of deep space, so far from the sun. And most importantly, we'll see how we're finally going to get a definitive answer, thanks to a mission that is already on its way to Jupiter. Our first clue is actually something that's missing entirely. Craters. In our solar system, every object with a solid surface takes a constant beating from asteroids. Our own moon is covered in billions of years' worth of scars. But Europa, it's pristine. There are almost no impact craters to be found. You might find maybe 20 large ones across the entire surface. The small ones, they're virtually non-existent. Europa is one of the smoothest objects in the entire solar system, and that isn't a compliment, it's a mystery. It looks as if someone is constantly resurfacing the moon, scrubbing away every trace of damage. Imagine a road crew working just beneath the asphalt, patching every pothole the moment it appears. Except here the asphalt is ice, and the crew is some hidden internal force, methodically erasing every scar from below. This perfect smoothness isn't a sign of peace. It's a sign that something massive and relentless is churning beneath that surface. And the first hints of what that force might be came from an aging spacecraft, one that picked up something that simply shouldn't be there. The first irrefutable proof didn't come from a camera. It came from a ghost. It was an invisible force detected by the Galileo spacecraft during its 11 flybys of Europa in the late 1990s. While the world waited for stunning photos, the real secret lay hidden in data from an instrument that doesn't see but feels, the magnetometer. As Galileo swept through Jupiter's massive magnetic field near the moon, it picked up a strange anomaly. Europa had generated its own secondary magnetic field. Even more striking, this field switched on and off, pulsing in perfect rhythm with Jupiter's rotation. There is only one way that is physically possible. Something deep beneath the icy crust must be highly conductive. The prime suspect? A global ocean of saltwater. This was the smoking gun. That invisible field was a signal shouting the truth, that beneath Europa's smooth, frozen mask lay a hidden, liquid world. Once researchers realized what they were actually looking at, they took a second look at the surface images. Suddenly, everything finally clicked. Those long, intersecting cracks stretching across the entire moon weren't just a random pattern anymore, they were scars on an icy shell, one that is constantly fracturing because something deep below is shifting. Vast regions of chaos terrain, jumbled piles of ice blocks that look like icebergs frozen in mid-collapse, now told a new story. These were places where warm water had surged up from the depths, shattered the crust, and then flash-frozen once again. But that raises an obvious question. How can water stay liquid at negative 160 degrees Celsius this far from the sun? There has to be an internal heat source. And there is. Its name, Jupiter. Europa's orbit isn't a perfect circle. It's slightly elongated, constantly tugged and stretched by the gravitational pull of its neighboring moons, Io and Ganymede. Because of this, Europa is caught in a rhythmic dance, drifting toward Jupiter and then swinging away. Every time it nears the gas giant, Jupiter's massive gravity squeezes the moon like a rubber ball, and as it pulls back, that pressure releases. This endless cycle of stretching and squeezing, happening on the scale of an entire world, generates immense internal friction. Scientists call this tidal heating. It relentlessly bakes Europa's core from the inside out. Think of it like bending a metal paperclip back and forth. Very quickly, the point where it flexes becomes hot to the touch. Only here, this process has been churning away for 4.5 billion years. That's nearly as long as the solar system itself has existed. So we know the ocean is there, and we understand why it doesn't freeze solid. But that knowledge only opens up a far more unsettling question. If this ocean lies trapped beneath kilometers of impenetrable ice, how could we ever take a look inside? What if it's not just an ocean, but a permanent icy prison with no way out? Europa's ocean isn't just a layer of water, it's an entire world. Researchers estimate it could be as deep as 100 kilometers. To put that in perspective, the deepest point on Earth, the Mariana Trench, is only 11 kilometers down. Europa holds 2, maybe even 3 times more water than every ocean, river, and lake on Earth combined. But this massive aquatic world was locked away. In January 2025, NASA released findings from the Juno spacecraft. The data confirmed a daunting reality. The average thickness of Europa's ice shell is 29 kilometers. Imagine flying in a commercial jet at cruising altitude. You look out the window and everything beneath you, every single mile of air down to the ground, is solid, unyielding ice. Drilling through something like that isn't just a challenge. It's a feat of science fiction. The ocean was there, but it was in a prison. Just when it seemed we were at a dead end, the Hubble Space Telescope spotted something strange. In 2012, while peering at Europa, it captured massive plumes of water vapor erupting from the moon's southern pole. These weren't just cracks in the ice, they were towering geysers blasting into the vacuum of space at heights of up to 200 kilometers. That's 20 times the height of Mount Everest. The prison wall, once thought to be impenetrable, was starting to leak. An ocean locked beneath a massive shell of ice had finally found a way to breathe. But this was still just indirect evidence. A faint glimmer of hope. We needed something more. That something more finally surfaced in the most unlikely of places, the archives. In 2018, scientists decided to revisit old data gathered by the Galileo spacecraft way back in 1997. Wait, 1997? Yes. That data had been sitting on a shelf for more than 20 years, and here is what they found. During one flyby as Galileo drifted just 206 kilometers above the surface, its instruments picked up a strange anomaly. The magnetometer recorded a sharp spike, over 200 nanoteslas in just 3 minutes. Meanwhile, the plasma detector caught a sudden surge in particle density. Individually, these were just isolated data points. But when researchers combined them with observations from the Hubble Space Telescope, the picture finally became clear. Galileo had accidentally flown directly through one of those water plumes. It means we've had direct evidence for over 20 years. We were looking right at it. We just didn't know what we were looking for. This discovery changed everything. We no longer needed to engineer an incredibly complex drilling rig. Instead, we could simply fly in and catch ocean samples that Europa was already blasting into space. But in science, solving one problem often uncovers another, one that is far more daunting. The surface of Europa is one of the most dangerous places in the solar system. The moon sits deep within Jupiter's massive radiation belts. Every single day, its icy crust is bombarded by 5.4 sieverts of radiation. To put that in perspective, 5 sieverts is a lethal dose for a human being. This constant barrage of charged particles effectively sterilizes the surface, tearing apart any complex organic molecules. It creates a cruel paradox. The geysers carry potential signs of life right to the surface, only for the radiation to incinerate them, like fire consuming the pages of a book. So we have a way to peer inside without actually cracking open this frozen prison. But that leads us to the most critical question of all. The water is there. The chemical building blocks are likely there too. But what could possibly power life in perpetual, icy darkness, buried under miles of ice where the sun's rays never reach? For life as we know it to emerge, you need a specific recipe. Just 3 essential ingredients. First, liquid water. Europa has that covered. A vast global ocean. Check. Second, the right chemical building blocks like carbon. By all accounts, those are present too. That's another check. But then comes the third ingredient, a source of energy. You need something to fuel the chemistry, something to spark the reactions. And this is where we hit a massive problem. Deep in the darkness, buried under miles of solid ice, the only logical candidate is heat radiating from the moon's core. On Earth, we know how this works. Deep on the ocean floor, there are hydrothermal vents, what we call black smokers. Essentially, these are underwater volcanoes spewing superheated, mineral-rich water. Surrounding them, in total darkness and under crushing pressure, life is teeming. We're talking about entire ecosystems that thrive not on sunlight, but on pure chemical energy. For a long time, we assumed Europa's ocean floor would look exactly the same. It was the logical conclusion. But then came 2024, and that theory fell apart. New simulations show that Europa's rocky core is likely too cold for active volcanism. Wait, too cold means the magma simply cannot push through the thick layers of rock to reach the ocean floor. The most obvious source of energy just isn't there. It's a scientific dead end. But there is another process at work. It isn't as flashy as a volcanic eruption, but it might be far more significant. It's called serpentinization. This is a slow-burn chemical reaction that unfolds when seawater seeps into deep rock fractures and reacts with the minerals inside. This interaction generates both hydrogen and heat. It isn't much warmth, it's certainly no boiling geyser, but it never stops. It grinds on for millions of years, and this isn't just a wild theory. Back in 2016, a NASA study concluded that serpentinization alone could be enough to maintain a chemical balance in Europa's ocean, one strikingly similar to Earth's. More recent simulations from 2024 show that these low-temperature systems can remain stable for billions of years. That is more than enough time for the spark of life to take hold. So even in eternal darkness, an energy source can exist that is powerful enough to sustain life. Every piece of the puzzle is now in place. And right now, a spacecraft is racing toward Europa, on a mission to find the definitive answer. In 2023, we found carbon. The James Webb Space Telescope set its sights on Europa and spotted carbon dioxide right there on the surface, concentrated in a jagged, scarred landscape known as Terra Regio. This wasn't some random smudge, it was a consistent source rising from the depths, straight from the ocean. The implications were massive. It meant the water contained carbon compounds, the fundamental building blocks of all known life. The recipe was finally complete. The era of theory was over. The era of action had begun. On October 14, 2024, a Falcon Heavy rocket carried the Europa Clipper into the void. This isn't a proposal or a sketch on a whiteboard. It is a real spacecraft, and at this very moment, it's hurtling toward Jupiter. Its mission isn't just to observe from a distance. Its job is to taste that ocean. The mission plan calls for 49 close flybys of Europa. Some will bring the spacecraft within just 25 kilometers of the icy surface, lower than a commercial airliner flies here on Earth. If the probe detects a water plume erupting from a fissure, it'll fly right through it. Onboard mass spectrometers will snag molecules that, only seconds earlier, were part of a hidden, subsurface ocean. It is quite literally a direct sample. The spacecraft is scheduled to reach Jupiter in April 2030. That's when things truly get interesting. There are only two possible outcomes for this mission, and both are profound. The first possibility, Europa's ocean is sterile. The conditions are all there, but the life is not. That would mean life isn't just a natural consequence of chemistry. It's a staggering, near impossible fluke. It would mean that we are, in all likelihood, alone in the universe. Now, consider a second scenario. Europa Clipper discovers signs of life. Even if it's just the simplest microorganisms, that discovery might be even more terrifying. It would mean life emerged independently twice in just one solar system. And if it happened here, it's likely happening across the entire galaxy. The universe would be teeming with life. Any organisms on Europa would have survived in total darkness, under crushing pressure, for far longer than complex life has even existed on Earth. Our messenger is already on its way. It's hurtling through the void to bring us an answer not from us, but for us. And whatever that answer turns out to be, it will change everything.